So I want to introduce then quickly the three companies. We always start with the one that is the furthest away, which is Hydroloop. And then we'll come back toward the United States and toward San Diego. And that second one will be from Canada, Tradeworks Environmental. Finally, it'll be WinWerks, which is one of our local members. And then again, about 8:30, we will wrap it up and start Q&A. And Nick will come back and the companies have put forward some questions, but we encourage all of you also to bring your questions into the chat feature. What I'd like to do, Sabine, if you would like to take over and introduce Hydroloop, we look forward to your presentation and then, of course, going to the Q&A afterwards.
Yes, of course. Okay, can you hear me?
We do, and we see you as well. Thanks, Sabine.
Wonderful, thank you very much. Well, good morning, everybody, or wherever you are, maybe afternoon, like where I am in the Netherlands. My name is Sabine Stivren. I'm the CMO and co-founder of Hydroloop. Now, Hydroloop Systems is a global leader in designing and producing innovative and game-changing decentralized water recycling products. And you see some of them here. And I'm going to talk to you about decentralized water recycling and creating a sustainable future. Use water twice, that is our motto, and you will hear that a bit more in my presentation. Now, the challenge the world is facing, Nick was already talking about it as well. You know, we have this hydrologic cycle and it's provided us for billions of years with sufficient supply, but it is insufficient already. And this is due to climate change, pollution, dropping groundwater levels, and it will become even more problematic with a global population growth of over 2 billion people in the coming 30 years. And we all need water. Now, how much water is there actually available? I just want to visualize it for you. You know, 70% of the Earth's surface is water, but only 3% is considered fresh water. And of that 3%, 0.3% is usable and drinkable. And it's that tiny little blue ball on there. So it just gives you a bit of an idea how little water we have. Now, to focus just on the States for now, if you look at the US Drought Monitor on the right from the 16th of February, if you look at the coloring, the white is there is no drought. But any coloring from yellow to dark brown goes from abnormally dry to moderate, severe, extreme to exceptionally dry. And this is February this year. So the water crisis is growing. The legislation is luckily evolving. Water companies are becoming engaged. Water and sewer rates are steadily on the increase. And of course, it will all become so much more problematic with that population growth. So it's code red for the world, but also America. And these are some of the current trends and research, and they are substantiating our vision that I will be talking about. But just to highlight a few, on the left, you see the 50 Litre Home Coalition. This is led by Procter & Gamble, talking about only using 50 litres per person per day in the house. Or in the middle, you see the Forbes paper, as day zero approaches, home builders need to prepare. But also on the right, UNESCO, water reuse within a circular economy context. So what is our vision of the future? Use water twice. Because we can be so much more efficient in the use of water by using decentralized residential water recycling as an alternative source. And we look at it like this: every building has its own water source. And if we at the building recycle this water, treat it so it's clean, clear and safe, and reuse it again, with this we can save up to 45% on tap water supply. And we also reduce our wastewater with 45%. And then to think about what kind of water we can treat. Well, the input can be air conditioning condensation water, heat pump condensation, bath and shower water, washing machine and hand basins. This is the water we can treat. And after it's been treated, it's safe, clean, disinfected, and it can be reused for flushing toilets, washing machine, garden irrigation, and topping up the pool. Now, just briefly about our treatment process of the Hydroloop, which is award-winning. We don't use filters or membranes or chemicals. Chemicals, not sustainable, you understand that. But why no filters and membranes? Because they're used everywhere in the water industry, and all our competition uses filters and membranes. Well, because they clog and they need a lot of maintenance. And we wanted to create a consumer product that is fit and forget, and that needs very, very, very little maintenance. So what we have created is a unique water treatment technology using sedimentation, flotation, dissolved air flotation, foam fractionation, and MBBR. And the final step is UV disinfection. And this is our patented technology. And obviously this water is clean, clear, safe and certified. And it meets all, or many, not all, but international standards such as the NSF 350, which is a very, very high standard to reach. And visually on the left, this is how the water goes in. And on the right, this is what it goes out. Now, all our systems, our Hydroloop systems, are remote controlled and monitored 24/7, all processes. And this gives proactive maintenance advice and over-the-air software updates. And again, this information is fed back to the app for the customers, which enhances their awareness. They can find the optimum in water efficiency, but they can also change their priority settings. And this empowers our customers to choose what to reuse their water for. Do they want to use it in-house, or do they want to use it for garden irrigation, or maybe topping up a swimming pool? Now, if we look at return on investment, this all depends so much on where you live, the region, the municipality. So it can be between 2 or 12 years, your payback time. But what are the benefits? Let's quickly look at them. 45% saving on tap water, 45% reduction in wastewater, saving on wastewater and water bills, energy reduction, carbon footprint reduction, increased property value as it complies with increasing regulation sustainability requirements, and becoming more resilient and less dependent on the grid. And let's face it, why should we talk about ROI when we're getting close to day zero? Now, what are our products? This is what we came out with as of 2018, and we've sold it in many, many, many countries. And this is the Hydroloop H300. And basically what we recently came out with is the bigger version, which is the H600. So this is for larger families or small bed and breakfast, or in areas where they use more water. And this is for commercial use. So now we can do larger operations, so student housing, sports clubs, airports. This is modular, scalable, and made to measure, and complies with and contributes to BREEAM and LEED certification points. Now, to just put a face to it, and this is actually from last September, and I just have to tell you that we are now 23 staff, so we are growing quite rapidly. But this is to give you a little image. This is actually at our head offices in the Netherlands, of part of the team, which is expanding tremendously. So, but we're not just selling a product, we're selling a vision. Build every building recycle ready, build them for the future, prepare them for the future. And it is very inexpensive to do that right now. And these are some examples that we are doing right now. So this is a smart city blueprint project that we're doing right now in the Netherlands. These beautiful homes on the water side, gas-free with solar panels, built with recycled building materials, and they're all built recycle ready and installed with Hydroloop water recycling systems. And these are some other happy customers. So we have end users, just, private people, but these are also happy customers. This is a very high luxury lodges in Namibia. And this is like a 350 student flat in Belgium. Very proud to be featuring as one of the solutions in the Brave Blue World documentary on Netflix, starring Matt Damon as well, and Hydroloop. Please go and have a look. And of course, very proud to be contributing to 4 of the United Nations Sustainability Development Goals, and having been chosen best of the best last year at the CES in Las Vegas. And you can see some other beautiful prizes and awards that we've been winning. So what is our ask? Well, after worldwide demand due to winning the CES 2020, and if you look on the world map, you can see where we already have our partners. But we are expanding our global partner network. And what we are looking for is to talk and also make connections with architects, with real estate developers, installation partners, water utilities, wastewater treatment companies, and local and city governments. And please, this is our slogan. And let's think about it again. Be wise, use water twice. I thank you so much for this opportunity, and for the second opportunity of talking to you.
Thanks, Sabine. We'll do what we can to try and pull the two together when we do the recording. Great job. So Minnie, go ahead and get started.
Excellent. Good morning, everyone. Thank you so much for the opportunity to introduce Tradeworks. I am the founding partner of Tradeworks Environmental. I head a suite of environmental technologies and an incredible team of scientists, engineers, PhDs. We're all united in our commitment to really do something to address the challenges that Nick very clearly identified are affecting society today. Municipalities and industries are facing an increased pressure, and traditional methods that typically address these problems fall short. Build more, increase your footprint, spend more, or optimization, process optimization through microbiology has fallen short, hasn't been predictable, and so the solutions available today are not, they fall short. So we have spent quite a bit of time with our team developing solutions targeted to address those challenges that society faces and industry and municipalities face. So our company is really focused on supporting the circular economy by enhancing waste to energy facilities and enhancing waste to reuse facilities, composting facilities, and we offer scalable solutions for municipal and industrial wastewater treatment facilities. We are an integrated solution designed to really work with the existing infrastructure and optimize the performance of those systems. Our solutions essentially enable our customers to really meet their sustainability goals. We're headquartered in Canada, but we have a growing network of agents and distributors around the world to support some of our applications. So what do? We utilize a suite of microbial formulations, the Hydra series microorganisms that are 25 formulations designed to enhance and optimize the biological treatment process. Our microbes take different metabolic pathways to degrade waste, so they're able to provide optimized efficiency, and combined with the Hydra process, which is the analytical capabilities that we have to systematically target improvements of the microbial community's performance. In addition, we've developed a piece of equipment, which is our prime screen. It's a biologically enhanced prime screening for headworks. And our team and partner network really brings decades of experience in really understanding holistically how to optimize these systems and support our applications. And that's one way in which we're different. A lot of other bioadditive products have a product that they offer, and our solutions are really tailored. And we use an analytics-based approach in how we use our microbes, and we are a cost-effective alternative to some of the conventional treatment and chemical options. And because we integrate, we're able to use the existing footprint to do more. And again, our expert team acts as an extension of staff, which is really the key in ensuring optimization. One key aspect about our technology fundamentally is that we focus on prevention. By targeting the source of what causes the problems versus treating a symptom, we can avoid common problems in biological systems such as odors, fats, oil, grease, and a lot of the unwanted byproducts that come with these systems. So not only does this drive performance benefits, but it saves money. So I want to provide a bit of an example in terms of the different areas that our technology can be applied in the different markets. I won't be able to get into too much detail on each one of these, but I will give you enough of a sense of understanding of how flexible, adaptable, and effective our technology can be in the various markets that I note here. So the first example I want to show is the application of our Hydra series microorganism product in a sewer grid of a municipality. By dosing the product in manholes and lift stations in the collection system, we are able to precondition the water before it enters the treatment plant. So in addition to handling odors and FOG reduction, the influent quality becomes improved, resulting in more downstream benefits and less cost to treat the incoming water. The next example I'm going to show you is an example of our prime screen solution. We are really focused on targets and objectives and helping facilities meet their goals. And in this particular application, our objective was to really help this facility get back into compliance, as well as they were experiencing high organic loads in their treatment system, and they were looking to reduce their energy consumption by 25% in their aeration stage and really provide a safe, clean environment for their operators. So this image shows our prime screen. It has a unique design and offers multiple operational benefits. And we are able to produce water quality coming out of this screen that is equal to or better than primary clarifier without a primary clarifier. And this picture shows how clean the screen is after about 2 years of operation, where the waste sewage flows in. It's an inside-out screen, and there's no accumulation of FOG. And the automatic bagging is a safety feature, preventing contact with the screenings to the operator, but as well, it provides process optimization because the screening that normally the inorganics are not entering the treatment plant. Another example of how our hydro process has helped a wastewater system extend the life of the asset is this facility in Halifax that was facing the difficult challenge of decommissioning because of operational performance issues and non-compliance. Strategically dosing locations within the collection system, we were able to provide the primary target as well as many secondary targets, with the end result of extending the life of this facility and protecting this asset. And underlying our hydro application is our strong analytics capability to really validate the results, optimize our performance, which is a key differentiator from other microbial products. And this slide, although a bit busy, is really there to illustrate the example of the output that we produce, where we take complex data and we are able to synthesize it and provide the right tools for the facilities to make the right decisions and really help to optimize our performance as well. And really that's the key to process optimization, that workability and the ability to analyze that information effectively to make the right decisions. So whether we're applying our technology in wastewater or in organic waste to reuse composting facilities, or as this example illustrates the benefits in anaerobic digestion and all the different benefits that we can achieve, the underlying commonality in all our applications is that we can improve the efficiency and increase the system capacity, which ultimately results in helping achieve a better return on investment for many of these systems. And we tailor each application according to what the target objective is and what the result that we need to achieve. And ultimately, we also support lagoon and water body remediation. Water connects us all. And as Sabine showed in her presentation, it's a very finite resource. So it's really important for us to work together to preserve, protect, and rehabilitate these precious water resources. And we work to really support a triple bottom line for our customers. We tangibly quantify the societal, environmental, economic benefits, and we expand our applications worldwide, and we still have a lot more work to do, and we are very encouraged with the response that we're getting so far and work with groups that are interested in innovative and clean solutions for our future. So we work very closely with many academic and industry groups to verify our claims. We use grounded science and third-party attestations, and we really work to be a support to our clients and help them achieve their sustainability goals and help them to gain recognition using our team's resources as well as the solutions that we are able to provide. And we work at aligning our solutions very carefully with the SDG goals to be able to provide a quantifiable, measurable result, and we can calculate the reduction in greenhouse gas emissions that we can provide for clients that are interested in monetizing. And what we're looking for, and I put this out to everyone, is we're looking to build relationships. We're looking for customers, we're looking for strategic partnerships, because ultimately that's the key to really moving the global needle on sustainability. So thank you so much, and I look forward to connecting with you.
Minnie, thank you. That was really very good. So without any further ado, we're going to go to our third presenter, Kurt Tetzlaff from WinWerks. So Kurt, over to you.
So greetings from Denver. I flew in from San Diego just before the recent blizzard and got a chance to even shovel some snow, which is kind of a new experience for me. Anyway, what I've been asked to do by TMA is to talk a little bit about how we can vet and integrate new technologies into our value propositions, and that'll provide some examples of one of our key water technologies, which is based around Powell Water Systems electrocoagulation. My background is I'm a third-generation developer and design builder, and my education is along civil engineering, construction, real estate development, and my master's is in business and in marketing. So it fits really well into becoming a water developer. So about 10 years ago, we got interested in alternative power, and then we migrated about 5 years ago into water. And as you've heard earlier, expanding populations, not a lot of water left, 0.5% of water on the earth is usable, and we're really messing it up. A couple of these pictures, one's from Texas and one's from San Diego in my neighborhood. And so how do we fix this? It's challenging. So what WinWerks did was basically put together a collective that could be organized to address owners and project sponsors' water problems. I think one of the things we've all recognized in owners is most of them are very risk averse. They have high expectations of a fast return. They don't really make a move unless they're forced to by a disaster or an impending disaster. So around that and in that environment, we've basically tried to reduce their risk by the way we design and build. We use the design builders from the Water Design Build Council. They've been vetted. We like to think of our teams as competent and committed, good communications, and also good chemistry. Our technologies are both in the energy and in the water markets. Electrocoagulation is our key technology. If we have to bring in UFNRO, we have relationships with Suez on that. With respect to operators, we can either integrate with the owners and support that, turn it over after commissioning. We can also bring in Suez or Veolia or others to operate the plants that we build. With respect to vetting and marketing, one of the things that TMA has asked is we do go through a careful vetting process of technologies, and if we can make our solution better, we're all for it. So we look at a lot of projects or technologies or processes, and we vet them from the engineering side as well as the marketing side, and how we can put together a marketing plan to get that particular technology integrated. And of course, money. Everybody's interested in money. One of our key guys is an ex-Bank of America equipment executive, financing executive, and Jack Goodman is our point of contact for financing that. So an owner can come to us or a project sponsor, and we can give them a complete package depending on what their water problem is. So using a case study with electrocoagulation, that's a concept where we basically, with Powell Water, we electrocute dirty water clean. And it's got applications across the market. And we are also going for zero liquid discharge when we can, complete recycling on a continual basis. But some examples of what the electrocoagulation will do is take dirty water and make it clean. This is coal water down below. This is an example of just some dirty water. And then that's actually a wastewater to drinking water picture. So during our vetting process, we found that Powell can remove a great deal of the suspended solids, the fats, oils, and greases. Recently, we've been doing some studies on PFAS, where the advantage is it actually destroys the PFAS instead of just capturing it like activated charcoal or carbon and or resins. It also kills the pathogens, and it produces reclaimed water from Title 22 standards in California to indirect potable or direct potable. And we don't use chemicals or biologics to get to that status. These are some third-party lab results of the effectiveness of a 1-minute treatment of electrocoagulation. It's quite interesting that by taking out the manganese and the calcium, we can actually reduce scaling in cooling plants, and there's some other advantages there. Killing the pathogens up to log 5, and we talked a little bit earlier about the PFAS. All of us in the water business know there's a lot of competition out there. Someone in Minneapolis told me there's like 600 different ways to get water clean, from the traditional biologics to the membrane technologies. And electrocoagulation, which has been around about 100 years, is now coming into its own. It's actually being taught at Red Rock Community College, which is the nation's second largest wastewater and water treatment training grounds, and happens to be in Denver. So what we've said, after looking at all of the market opportunities, we're going to concentrate on municipal wastewater, landfill leachate, and PFAS. And in that way, we're looking for alternative technologies that can enhance our treatment trains. Right now, our plan for landfills is basically to take water, clean it up, destroy the PFAS, put the solids back in the landfill, and have a clean discharge. If there's salt involved, we'll bring in filtration and reverse osmosis, treat the concentrate, and again, run it through the cycle. The big deal here is this is a lot less expensive than the alternatives from what we can tell. And this is a project that we're working on where a municipality is running out of water. We are proposing a 7 million gallon a day treatment program. They're providing the water through their wells and solar power, and we'll basically treat the water and then mix it in with an existing potable plant to supply about 7% of the community's water. This is one of our inventions that has been patented and is really exciting. We built a company called Agua, and it's designed to work in small cities, few hundred people to 10,000 people, and basically allow for primary and secondary treatment through microalgae, and then we'll kill the pathogens with electrocoagulation, and we have EPA discharge. We've had a plant running for 8 years in Hydro, Oklahoma. It's open for tours, and it's also very expandable. So what's our ask? Basically, we've got an incredible team and options to custom fit to a client's needs. So we're really looking for prospects that can become clients. And so we look forward to bringing in new technologies and collaborate and bring more effective, cost-effective and quality-effective solutions. And we kind of talked about it earlier. We're looking for people that we can get along with, that are committed to wastewater to water use, circular economy issues, and have enjoyed their work and have some fun. I'm available to call. We can put together paper studies and pilot studies and implementations, and welcome the introductions to you. Mike, it's over. Michael, it's all to you. Back to you.
Well, thank you very much, Kurt, Minnie, Sabine, and I'm actually going to turn it over now to Nick to moderate the Q&A, and I'll invite the 4 of you to make sure your cameras are on and you're unmuted. Everybody else, please, if you'll stay muted and have your cameras off, we would appreciate it. So, Nick?
Yep, appreciate it, Michael. And if anybody does have questions, do put it in the chat there. We'd love to answer some of your questions as participants. Impressive stuff. Appreciate the time, Sabine, Minnie, Kurt. I've learned a lot. So want to start maybe ladies first here with a couple questions. One being something that I've kind of focused on more and more recently was there seemed to be a lot of conversations around centralized treatment systems versus decentralized, especially when you think about large infrastructure. You know, with the US, it's 30 to 40 years old, and we're really kind of focused on that now? Do we rebuild these gigantic centralized systems, and is that the right approach? So I'll start with you, Manny, and then I'll come back to Sabine. How does your technology reduce the need for these bigger and larger infrastructures?
A key aspect of our technology is to leverage the collection system for municipalities in particular. So the municipality is, the collection system is typically an infrastructure for conveyance, and then treatment happens end of pipe when it enters the treatment process. We leverage that collection system that has optimum conditions for preconditioning of water, so we can significantly reduce the organic load to treatment plants. So where there's industrial contributors or technologies that reuse water and add a higher organic load, we can reduce that organic load, and along the way also get rid of all the odors. It's like cleaning up the arteries and making sure you have good health within a municipality. And that, in combination with our prime screen, helps us to essentially skip stages of treatment processing.
Good. I like the analogy, the health analogy. It's very, very, very relevant. Good. So kind of building on that then, Sabine, how do you see utilities responding to gray water technology? So I see in California, they're starting to talk a lot more about water reuse and the utilities providing reclaimed water as a source of incoming water. Do you see utilities responding favorably? And maybe if you can get an impression of Europe versus North America, that would be ideal as well.
Yes, I can. Well, in Europe, not so long ago, a couple of years ago, we were actually the competitor of the water municipality because they saw us as a threat. But now, because things are changing, for example, Belgium, which is our neighbor country, is the 21st driest country in the world. It's number 21 on the list. So you can imagine that bordering Belgium, it's also very dry in the Netherlands. And so basically, you see now that the water municipalities, they have a really big problem because they have an obligation to supply water, but there is insufficient supply. So they're having a real problem. So their whole business model isn't working anymore. So we are now actually in Europe, with many of them in Europe, in England, in Belgium, in the Netherlands, but also we're doing a lot of conversations now with Sydney Water in Australia. We're actually looking to work together with them and even have our systems, for example, supplied so that the water municipalities will install systems with their customers and will meter the grey water, will meter the water, and it will become more like water as a service. So there's a lot happening, but it's a tanker. It's been a tanker, so to speak, and we were like the little rubber boat pushing that tanker into another direction. And if I look at America, I think a lot is happening as well, depending on different states. But yeah, in general, utilities are a bit cautious, so I would invite them to expand their thoughts. And, because, this is a global crisis and, we must, the solutions are there. So we should adopt them far more quickly.
Yeah, it's a good point. I mean, I think it's just that psychological change of mentality, right? You gotta think differently, and then you gotta be able to collaborate. There is a real quick build here, it looks like, in the chat. So asking specifically, Sabine, do you see that culture changing? Do you see people being more open to water recycling and using gray water? So some of your technology is home-based. Do you see people feeling comfortable with that?
Yeah, because, for example, in Europe, for example, we just co-wrote a new standard. And basically, the standard, so in America, you have the NSF NC 350, which we comply with, which was very stringent, and we meet those requirements. So people can be assured, this is a quality label, can be assured that our products and the water that comes out of it is clean, clear, safe. It's also disinfected. I mean, I've drank it. You can see I'm still here. It's not supposed to be drinking water, but I didn't die. But basically, what our system does as well, to give you an idea, when the washing machine takes water from the Hydroloop, it is our system is more like a telephone with a few water tanks on it. It's very high tech. And so we make sure that the third cycle in the washing machine, the Hydroloop will not serve recycled water, but will switch over to tap water. This is like just like the psychological idea that, you know, your white shirts will be clean, but you can change that on your app. So if you don't want that and you want to reuse all your water. So, but yes, it is a mind shift, and some people are much easier with it than others.
But you make it practical, you know, by that kind of example, but then using technology which people are comfortable with.
Yeah.
Good. All right. So Kurt, my fellow Denver friend, I've got one for you heading your way. So it kind of builds off something in the chat here too. I mean, one of the challenges I've always seen with water is people think it's low cost and therefore low ROI, right? The cost of water is very low because they don't think about the true cost of water. So how do you look at that? Because you talked a little bit about the financial part. Your team is very savvy with that. How do you determine the viability of a project and the ROI? Can you give some insight there?
Sure. I think what we discovered, and what I discovered when I first got into this, is how expensive water really is. The first project that we looked at was at UCSD to recover wastewater for the cooling towers and their microgrid. And we're, you know, in California, we're spending $8 plus 1,000 gallons, and wastewater is around $6 1,000. So you're up around $14 1,000, you know, maybe. And so what we do is we take a look at how much electrocoagulation we have to do and treatment to, you know, what's coming in and what's coming out. So we do an engineering study on that. And then that determines what our CapEx is going to look like and our OpEx. We got a really extensive financial spreadsheet that basically kicks out return on investment, paybacks, savings to investment ratios, discounted cash flows, all that good stuff. And then, you know, you sit down with the owner and you basically simplify it depending on who's at the table. But what we found is that there's this unreasonable expectation about this 3 to 4 year payback, right? I mean, who's making 33% on their money these days? And it's pretty crazy. And that's why we think that by giving them the whole system and even owning it, it's like, don't worry about it. Just pay us, you know, something less than you're already paying. You're happy and we're good.
Good. Can I always say to people when they talk about ROI, I say, so what is the return on investment of your car or of your kitchen or your wife?
Yeah, it's interesting. I mean, I appreciate you, Kurt, you gave those real number examples in California, because I think that's, you know, a good beacon of where everybody else is probably going to be sometime soon, just especially with upgraded infrastructure and the need to recoup and do preventative maintenance on a lot of infrastructure. You kind of have to start looking at that real cost of water. But, you know, what we find in a lot of our analysis is that it's usually 2 to 3 times what people think they pay. You know, where an organization thinks they pay a certain amount, it's usually 2 to 3 times higher than that even. When you think about, you know, the energy to move water, to heat and cool water, the chemicals, the filters, you know, et cetera, let alone all the other kind of reputational stuff and brand stuff associated with some companies. You know, you got to think about kind of the whole package. So that's a good one.
Dan Hendrickson on one of our studies came up with, I think to move an acre foot of water is over 3,000 kilowatt hours. California uses 20% of its electrical power to just move and treat water. So keeping it local, like San Francisco, where anything over 250,000 square feet has to be locally treated. We're looking at some of those systems to take black water, convert it, and then use it for the Title 22 reuse water at a distributed basis.
Yeah. No, that's really the key, to keep it within the same basin to the maximum extent we can. So good. All right, Manny, I want to shift over to you. If you want to talk, you know, if you want to respond to the return on investment kind of cost of water, that's great. But then maybe if you could talk a little bit about your prime screen, because that seems to be really fundamental to your technology. So if you could provide a little bit more insight on that.
Excellent, thank you. So yes, return on investment, my comment on that is Sabine had an excellent illustration that shows really the impact of water scarcity. So, you know, it's something we need to create more awareness, and education will support this. This platform is one way to really educate on the importance of the, teaching people that that invisible infrastructure costs money. And so our angle in what we try to do is really use existing systems and optimize them and really support, just be a supporting act to some of the existing providers of circular economy technology, like composting facilities or anaerobic digestion facilities, or even municipal wastewater treatment, so that we can help improve that ROI through efficiencies in reducing the processing that's required. So our prime screen essentially is a fine screen technology. Most municipal applications have bar screens, and people use the toilets, unfortunately, as garbage receptacles. So there's a lot of stuff that's thrown in the collection system that end up in the treatment plant. And fine screens are not often used because of clogging. They have a specific focus, primarily with membrane technologies and some other sensitive systems. But we found that by adding our microbial formulations as a probiotic or preconditioning of that water, the illustration that I showed of that, the inside of our screen, aside from the fact that it has a unique design, sewage flows in and out. So the key difference with our screen is it prevents bypass. It prevents the inorganics that would normally burden the treatment process and add more treatment demand, energy demand into the process. And the synergistic effect of the microbes help to eliminate odors, precondition, and create a clean screen. So that's one of the rate limiting steps to fine screens, right? The clogging. And so through our use of the microbial formulation and our fine screen, we're able to clean water equal to or better than a primary clarifier without a primary clarifier. So it's that clean. So some communities that may not have optimized treatment facilities, or not even have a treatment facility in some parts around the world that we're looking at, we at least can help improve the quality of that water because water is such a finite resource.
It's good. It's interesting. It's also the lower maintenance, I would assume, and those kind of aspects too. Less labor intensive.
That's the key aspect. Our screen was designed with operations in mind. So you saw on the outside, everything is changed out. The panels can be changed out, and you can step down to a finer screen from the outside. And so it's a safety. It's all automated as well, and can be controlled again from an analytics data board. Good.
So I want to remind everybody, their contact information is in the chat if you want to reach out directly, either shortly after this, but then also put your questions in there. I see a couple of comments coming in, so this is great. I want to go to Sabine with a question, and then Kurt, I'll come back to you because there's a question in the chat if you can take a look around PFAS, which obviously is getting a lot of attention. So Sabine, I know that in-house water filtration units and units for businesses like hotels, et cetera, have been around for a while. What kind of makes your technology different from those traditional ones and your kind of main competitors? It'd be great if you could speak to that.
Yeah, well, the interesting thing is that, there have been and there are already quite a few products on the market. And so, like, for example, in America, you have Greater. And there are some others worldwide. But the interesting thing is, why haven't they taken a flight? Why aren't they around like tremendously? Why is that? And our vision and our is that basically, if you look at them, they are basically technical solutions. They are not consumer products. They are big, bulky. You need a shed. You need an extra room for these kind of units. They're quite technical. You get like a box on the wall with a flashing light, and they all use membrane and filter technology, which, as I said before, I mean, it works fantastic. But in the water utility industry or whatever, you have a maintenance team, and they will treat and clean these membranes and filters, which is a dirty job. But you don't want to have to clean your filters every 2 or 3 months yourself, or have somebody come and clean and treat them. So the main objective, what we wanted to do, is create a system that would at least for 1 year not need any maintenance or servicing. And that meant that we had to go completely out of the box and not use filters and membranes or chemicals. And that's how we came up with trial and error with what we have created and patented. And then, of course, you can see them behind me as well, I mean, it's a consumer good. You want to be proud that you are a water saver, so it has to look good.
Yeah.
You know, it has to look good, and it has to have a small footprint. So those were a few of the design goals that we did. So that what differentiates us.
Well said. I mean, I think you're spot on, and it's nice. I mean, you've obviously been successful with it, but bringing in that consumer part of it, because I think a lot of times people think, well, I have to have a big problem. I have to have, you know, unsafe water that I'm drinking in order to invest in a household unit, and that's not the case. It's about enhancing your life and enhancing your lifestyle and thinking
exactly.
longer.
And we are foreseeing with the trend that is happening, you know, and what has been happening for the past years, and it's our vision that within 10 years' time, it will also be legislated in many places that water, you know, needs to be saved and recycled, and that within 10 years' time, no new construction will be built without its own decentral water recycling systems, and that water recyclers will become, you know, as normal as air conditioning units and whatever, which of course, with the economies of scale, will drive the price down tremendously, and hopefully it's going to be a no-brainer, you know, to have a system.
Right? Yeah, it's part of our lifestyle, and. Haro, I think that answers your question there. He had asked about new developments and whether this will be just fundamentally integrated, especially in, say, California, which it probably will happen in some progressive areas first.
We're talking to Culver City right now, which is so.
There you go.
Nick, I just wanted to add one point just on the tail of Sabine's comment, which I think is an excellent comment, which she stated that it's legislation. So I'm a believer that regulation or legislation creates the pathway and fosters innovation, not the other way around, because we have a lot of great technologies here, and the barrier to entry is often the industry in the way it's set up. And regulation and legislation kind of pushes the adoption of some of the technologies that we all here are utilizing. So I think that was a very good point, Sabine, and I just wanted to highlight that as terms of, I'm sure all of us on the call here are finding that's a barrier to entry for these innovative clean technologies.
Absolutely, it's a great point. We see it a lot with our clients where it's just a disincentive. Like they want to do the right thing, they want to recycle and reuse water, but that removes revenues going to the utility. It reduces the constant flow to that utility, and so there's kind of those disincentives that are set up there, unfortunately, still, that have to be worked through. And legislation and policy obviously plays into that. So,
can I add one thing to that?
Yep.
So, design build. What WinWerks logo is we've shifted the traditional delivery of product around, because architects and engineers, as much as I love them and they're dear to my heart, they are not necessarily the most efficient at delivering on a process. And we've had engineers tell us, why would we use your system? You're half the price. And we get 10% of whatever the capital cost is. So yeah, it's frustrating. That's why we want to control the whole package and get around that.
Yeah, well, it needs that system look, and we need to be innovative and kind of break those old ways of thinking in a way, because things have changed and technology is obviously changing. Good. Speaking of that, there was a question in the chat here, Kurt, that I'd kind of teed up for you. So the question's around PFAS. PFAS and similar chemicals are obviously getting a lot of attention. They're significant challenges globally. Can you talk more about how your technology addresses a lot of those persistent chemicals and substances? I know you had mentioned that that's kind of where a little bit you're shifting your attention to. So could you speak to that?
I can. Now keep in mind that, you know, in our business, we're always getting ideas and problems thrown across our bow, and we sometimes can respond to it. My chief engineer, Dan Hendrickson, loves new challenges. And so when PFAS first started to show up a couple of years ago, I was really happy that I could spell it. And then after that, he had me read a book called Troubled Waters, and then I just finished a book on Tom Rivers, and the amount of pollution and the cancer productions that occur out there that are hard to catch, and PFAS at 1 trillion parts per million is hard to catch, and it wasn't being found out. So we have just in the last 6 months really started to get into PFAS. We're doing pilot studies right now. We're making a paper to ERIF, which is the Solid Landfill Association. And so the one takeaway that I've learned is that we destroy the PFAS, the activated charcoal and the resin systems just capture it. You still have the problem. And we watched a presentation last week with cost 4 cents to UFRO the leachate, cost 8 cents to encapsulate it, and then they would spray it back on the landscape or the landfill face. It was horrendously expensive. Our numbers are so much smaller, and you got rid of the PFAS. So I think there's hope there. I think there's a huge differential advantage. I think that PFAS is still a real work in progress. We're going to learn a lot of stuff. I mean, the EPA, I don't think really is spending a lot of time on it, and they could take 20 years to come up with a solution or a limit. Texas has, what, 700 parts per trillion for PFAS. California, I think, is moving towards 14 or 7. So,
do you see a lot of coordination on the issue between states and between organizations, or do you feel like it's still kind of disparate?
I would say I can't answer that accurately, Nick.
Sure. Okay. A few more minutes here, I know, to keep talking, but please, if you have any other questions in the chat. So many, and this really is for all three of you. I mean, one of the things I see with technologies is customers struggle to see, is it relevant to them? So, there's no silver bullet. It's just not possible. So, Manny, could you maybe start? And what's your target customer? Like, if you could say, here's my ideal customer, is there a way you could kind of frame that for the audience?
Yes, so because we serve such a broad circular economy application, our ideal and how we find our clients typically for the municipal space is non-compliance. So where a facility is forced to do something and the alternative to what they need to do is to spend a lot more money, they're willing to try because they have nothing to lose. And so those targets of non-compliance are ideal for us. And as communities are expanding and they're bumping up closer to treatment plants, lift stations, the impact of things like odors and blockages, fatso, grease, etc., those create concerns for community. And those are the opportunities that are easier for us to get into because we're a last resort before significant capital. The other aspect is we're really talking about the circular economy and taking organic waste and doing something with it, whether it's converting it to energy or turning it into compost. And those processes sound really great in theory, but where we have a facility that has a high CapEx cost for setting up these facilities, to be able to effectively reduce the return on investment, that's a sweet spot for us by enhancing performance. So there is a place in the market for chemical, there is a place for biological, and we don't displace one over the other. In many instances, we complement the efforts. And so our ideal targets are typically systems that are challenged, and we can optimize them.
That's good. I mean, I see that theme about we complement other technologies. I think that's really important, again, because there's usually not one single silver bullet.
Exactly.
How about, Sabine, how about on your side? So I know you work with household, small commercial, as well as larger systems. Do you have ideal clients?
Yeah, well, yeah, I mean, yeah, well, it's many. I was actually just writing down, because it's like the leisure industry, it's the hospitality, it's, so basically it's quite broad. But what I'm finding right now, what we're finding is that if we get all key stakeholders together, like what we're doing now in the Netherlands with this one nice smart city, whereby this is where the municipality, the local council, the builder, and the water utility, and we were all working together. And if we collaborate like that, then we can make things happen and work, and then everybody benefits. So that's really what we are kind of trying to look for, to have this to find these collaborations.
Okay, very good. Good. With the last couple minutes here, I thought we'd just give you each about a minute to kind of have some closing takeaways. Michael, would that be okay, or do you need to wrap us up?
No, I think it's exactly what to do. Give them each 45 seconds.
There we go. You're on the clock. So we'll start with Kurt since we went last to begin. So there you go. Kurt, 45 seconds.
Okay, my ideal client is someone who can pick up the phone and yell help. From there, I think that it's wonderful that there's this collective of people that are coming together to try and fix the water problem. I don't think in California any water that comes in should ever go to sea. It should just be continually recycled, and we have that capability. And I think it's a wonderful business to be in with respect to making a couple of bucks, but also doing some really good work. So that's and we're available to help.
I like it. Minnie?
What do I want to say? So obviously I've came into this industry, like most of you, out of a passion to really make a difference. I really answered that call personally that, you know, we need to be mindful of our practices today and how they impact the future. And we've designed our services and our solutions in order to address specifically those issues. And really, I'm a huge believer in collaboration. I believe that it's the only way that we will really move that global needle on sustainability. And, you know, SDG goal 17 is about partnerships to really make that happen. And that's the only way we're going to hit the 2030 goals and really achieve great success. And we're here to be one small piece of that puzzle. And we have solutions that we're really excited to expand into the marketplace and really meet people like you, because it's through education that we create awareness, right? And that fosters adoption of new technologies. So thank you. Every drop matters, and every drop of support and every drop of effort is valuable. And together we create a wave of difference. And that's my take.
All right, I love it. Every drop counts, and we're in it together. All right, Sabine, you got to follow that one.
Oh, well, you know, 14 years ago, I think it's about 14 years ago, An Inconvenient Truth came out, you know, and this really was a paradigm shift on sustainability and on energy saving and carbon. And you know, and you can see what's happened. We're not there yet, but a lot has happened. And what we need now is a paradigm shift on the way that we treat and value water. And I truly, you know, we are here with a very passionate team. And this is also, we are not, you know, it sounds maybe a bit strange. We're not selling products. We're not selling Hydroloop. You know, we are trying to make everybody see that when you're building for the future, and that we should be future-proofing our buildings, build them recycle ready. The cost for that project developer or architect or whatever is almost zero. So it's like a washing machine. When you buy a building, you know, all the plumbing is correctly there. But the person, you know, the end consumer, I bring my own washing machine. So prepare those buildings, and let's be wise and use our water twice.
Future-proof, use it twice. All right, good. Michael, I think you have 45 seconds. There you go. You guys.
That's right. So Tamara, could you bring the last slide up that shows everybody's contact details? And while you're doing that, I just want to thank the four of you. We're going to end this by just showing kind of each of you. And I'm afraid, Nick, that we didn't get you on this same slide. But to Nick, Minnie, Sabine, and Kurt, you guys are great. What you're doing is important. We salute you at TMA BlueTech. We appreciate you participating in this month's monthly webinar. And I think, knowing that we had this practice on Tuesday, that some of you are going to be able to work together. And I think that's also a great benefit of collaboration. You've all talked about it, but we look forward to hearing about that as we go forward. And without any further ado, we want to adjourn at 9 o'clock. We run a tight ship here. And again, Nick, Sabine, Amina, Kurt, thank you so much for your work today. And we look forward to seeing you again in the future, and let us know how we can help. Thanks to everybody here and to our own partners, TMA BlueTech Cluster Alliance, the Brink at University of San Diego. And we hope that you'll join us for April for BlueTech Space and the Circular Economy, and in May for Ocean Sensors and the Circular Economy. So thanks very much. Have a great day.